Hello, everyone. Thanks for being here. My name is Demin, and today I'm going to talk about how to build an all-in-one application server using Swoole. So first, a little bit about myself. I'm a staff software engineer at Electronic Arts, and I have been playing with PHP for many years. Since year 2000, I'm a big fan of it. And I'm an open source contributor and a member of the Swoole team. About my background, I was born in China. I worked in the United States for a couple of years in different cities. Now I live in Canada. And you can find me on Twitter or GitHub. So here's what I'm going to talk about today. First, I will explain what Swoole is. Then I will discuss different server-side components like the web server, like task queue, like cron jobs. And then I will discuss how to put these different types of components together to build a server combo or an all-in-one application server. And at the end of this talk, I'm going to share some more resources about Swoole. And there will be a couple examples being used throughout the talk, and hopefully those examples are some interesting ones. So let's get started. So the first thing is, what is Swoole? You see, like in recent years for modern PHP, there's some cool things, new concept coming out, like serverless PHP, like asynchronous PHP, and like Swoole React PHP. So when coming to Swoole, people usually have some questions like this. So what is Swoole? And what can we do with Swoole? Or what are the differences between PHP FPM and Swoole? So here, I will try to answer some of these questions. So the first is, what is Swoole? Swoole, it is a PHP extension, but it's not the same as some other PHP extensions we used to use, like PDO, Opcache, or APCU. This extension, it focuses on two things mainly. First, it focuses on asynchronous programming, kind of like what you see in some other programming languages like Node.js. The other part is about concurrent processing, like how to do multiple things or multiple I/O operations simultaneously. And this part is done through a concept called CSP, Communicating Sequential Processes. So this talk, we are not going to talk about what is CSP and how it works, but I do have another free online talk talking about it, and I will share the slides at the end of this talk. So anyway, CSP is the fundamental concurrency model used by some other programming language, and it is also being used by Swoole to perform multiple I/O operations simultaneously. Okay. And on GitHub, Swoole is a pretty popular project. It has over 17,000 stars there. And in general, we should only use Swoole and the command line. People are always wondering, hey, can we use Swoole with PHP FPM together? A short answer to this question is no, we shouldn't use Swoole with PHP FPM together because most features in Swoole won't work there. So now let's take a look at the difference between PHP FPM and Swoole. Let's see if we want to build a website, and this website is pretty simple. We will print out hello world on every page of this website. How are we going to do it with PHP? Well, using PHP FPM, this is pretty easy. We just have one line of code, echo hello world there. That's it. We will leave the rest part to a web server like Nginx or Apache to handle it. That's how we do it with PHP FPM. But if we want to do it with Swoole, it's going to be different, because here, the PHP script written in Swoole, it itself serves as the web server. So as you can see from the second sample code on the right side of the screen, we need to create a server object first and listening to port 80. Then we have a callback function there listening to the request event, which means anytime there's an HTTP request comes in, this callback function will be used to process the request and send a response back to the client. We then call a start method on the server object to start this web server. So when this pieces of PHP script runs, itself serves as a web server, which means we don't have to use Nginx, Apache, or some other web server in front of our PHP-based web server. So, and this Swoole-based web server is actually pretty efficient or pretty fast. Let's take a look at a benchmark result. So this benchmark is done by a framework called Hyperf. Hyperf is a Swoole-based framework for building PHP applications. And from this benchmark, you can see we have 8 threads running. And by using these 8 threads, we keep 1,024 concurrent HTTP connections open to the web server, which means at any given time, there will be 1,024 HTTP requests made to the web server. And let's check the output. So here, if we check the output, we can see that in about 10 seconds, this web server could serve over 1 million requests. So on average, every second, the server could serve over 100,000 requests. Pretty efficient, pretty fast. But I have to say, now in this benchmark, we are not doing IO operations. Like what are IO operations? Database queries, API calls, DNS lookup, things like that. We didn't do much IO operations. So I would say if for this benchmark, okay, if we have some IO operations there, Swoole could perform even better. So let's check another example. So in this example, what we're going to do is that we have a for loop here that runs for 1 million times. And inside each for loop, we're going to perform some slow IO operations. Like, for example, like a slow database query or slow HTTP API call, something like that. But for testing purpose, we're going to use the sleep function call to simulate some slow IO operations here. So in this example, we will sleep for 1 million times, and every time we sleep for 5 seconds. The question is, how long it will take for this script to run? How much time? Almost 2 months to finish. And then the reason is because PHP, by default, it runs in blocking mode, even like when we need to deal with some IO operations, like for sleep function call. Okay, when there's a sleep function call there, our PHP process is kind of stuck there, waiting for the sleep function call or the IO operation to finish. Even our CPU doesn't do anything else right now. So now, if we rewrite the same piece of code using Swoole, and we need to modify it a little bit to make all those blocking IO operations work in non-blocking mode or asynchronously, let's see what will happen. Okay, but so here is the Swoole version of the same script. What we are going to do is first we will call a method called enable coroutine to allow IO operations work asynchronously. Then we still need to have a for loop there running for 1 million times, but instead of calling the sleep method directly, this time we will use the go keyword to create a coroutine first, then wrap the IO operation or the sleep function call in it. So here is a little concept here, a coroutine, which is created by the go keyword here. So what is a coroutine? A coroutine is just a piece of PHP code running within the same PHP process. It's just a piece of code. However, if we have multiple coroutines created within the same process, and each coroutine, they have some I/O operations defined or happening, Swoole allows these multiple I/O operations running simultaneously in different coroutines. So that's what is a coroutine. It's just a piece of code that allows some I/O operation runs asynchronously. So back to the example. So here we create a coroutine, then wrap the script function call in it. And we will see how long it will take for this piece of script to run. So just, I want to mention again here, we still have 1 million iterations here, which means there will be 1 million coroutines be created. And the result is that it will take less than 20 seconds to run those 1 million script function calls or creating those 1 million coroutines here. Less than 20 seconds. So looking at these two pieces of code, I'm going to draw two conclusions here. The first is that Swoole, it allows to perform multiple I/O operations simultaneously when processing the same HTTP request. The second thing is this. Now, you see, in PHP FPM, when there are multiple requests comes in, each PHP FPM process can handle one of the requests at any given time, or other HTTP requests. They have to wait until current request being processed. But in Swoole, it allows to handle multiple HTTP requests simultaneously within the same process. So that's why Swoole is a better or best choice for dealing with heavy I/O operations. Although I have to say Swoole is not a best choice for everything. And in many cases, I would say PHP FPM still a simple and a better solution, like for building dynamic websites. So just to make it clear. Now we know how to use Swoole to build a simple web server. But if we need to build some PHP application in a production environment, there are more things to do other than just to build a web server. So sometimes we need to add other features like cron jobs, like to add a task queue in our application, like to do background processing in our application. Now, how can we add all these different kind of features into our application? Well, there are a bunch of different solutions to do that. For example, okay, if we want to add a cron job to our PHP application, what we can do? Well, we can just add a cron tab entry into our server, or we could use some third-party system like Jenkins. In Jenkins, we could add a job there, then we trick the job to run once a while, to trick some cron jobs. Or what we could do is to trick a cron job through background processing in PHP FPM, just like how Drupal does. So a bunch of different solutions here. But look at these solutions. They have different side effects. Either they rely on a third-party system like Jenkins, or they have some performance impact on your server. Those implementation could slow down your server somehow. Now, here we are going to discuss how to add all these features to have like cron jobs, to have like task queues implement within the same PHP or Swoole-based application server. And let's check it. So because there are different components involved, so I'm going to split the discussion into 3 parts: the web server part, the task queue, and the cron jobs. We are going to discuss how to implement them in Swoole. So the first thing is about to implement a web server, and we actually have discussed it previously. So we have seen this example code before. So this is how we build a simple web server using Swoole. We create a server object listening to port 80. We have a callback function there listening to the request event. This callback function is being used to handle HTTP requests. We then call a start method on the server object to start a server. So that's how we build an HTTP server, and and we can build some other types of servers in the same way, in a similar way. But you see, there is something happening here. The request events in Swoole, there are a bunch of different events there, probably over 17 different events, and there could be more events being added. And these events, they are happening at different stages when a server is being started or when a server is running, and they are for different purposes. To help us to understand, how different events, I draw a picture like this here. And you can see that different types of events being grouped together and with different colors. But don't worry about it. Even like you see so many events here, you don't have to know most of them, because in many cases, we don't need to use them. Some events there, okay, they are just for some specific web server, like when you need to build a WebSocket server or when you need to build a UDP server. And some events here, they are just for some more advanced features, which we don't have to touch if we are new to Swoole. For example, if you just want to build an HTTP web server, okay, probably the only event we need to care about is just the onRequest event, right? So we see there are lots of things, lots of events here, and it seems to work differently than what we had played with PHP FPM. Now I have another question here. Comparing to PHP FPM, what are the differences when building PHP applications using Swoole? Or how would Swoole change the way we used to write PHP code? So to answer this question, I'm going to give another example. So let's say we want to build a web version of the rock, paper, and scissors game. And I would assume that some of us have played this game offline with our family members or with my friends before. So this game, it looks like this. Okay, we have 3 players here, and each of them make a choice by themselves. And when all 3 players make their choices, have their choices submitted, the server should show the result to all 3 players simultaneously. So it's kind of like this. Like the first player, player A, makes a choice, clicks the submit button. But once he clicks the submit button, we're not going to show a result to him directly, because we don't yet get choices received from other 2 players. So player A is going to stay here and wait for a response. Now player B makes a choice, clicks the submit button. Again, the server won't send a response directly, because we are still waiting for player C to submit his choice. Now, player C makes a choice, clicks the submit button. Once player C clicks the submit button, the server has received all choices from those 3 players. It should return a response to each of those 3 players at the same time, just like this. So we need to build a game, an online game like this. How are we going to do it? If I look at requirements like this back to a couple years ago, and if I need to implement it, there will be 2 things in my mind. The first is I will need to use sleep function calls, either on the server side or on the client side, just to wait and check to see if there's some result ready or not on the server side. And the second thing is I will need to make Ajax calls on the client side to see if there is a server side result ready or not. But if we implement this game using Swoole, it's going to be different. So let's see what we can do with Swoole to implement this game. So here is the code. So if we look at code here, okay, we will define two variables first. The first variable, it will be used to hold the HTML content of the form. Then another variable here, which is an array, it will be used to store the submissions from those three players. The next thing is we're going to create a server object listening to port 80. Then we have a callback function here listening to the request event. So all the HTTP requests, they will be handled by this callback function. And this callback function will handle two different types of requests, an HTTP GET request and an HTTP POST request. If the server receives an HTTP GET request, it will show the web form to a player. And when a server receives an HTTP POST request, which means a player is submitting a choice to a server, we are going to execute this else section here. So let's take a look at it. So in this else section, the first thing we do is to store the submission information into the array. Then there is an if statement to check if the server has received all three choices or not. So for player A and the player B, this if statement is false, which means when player A and the player B submit their choices, the only thing that is being done on the server side is to store their choices into the array. Now, but for player C, it's different. When player C submits his choice, this if statement is true. So what happens at that time is that the server will calculate a result, then iterate through the array and send the result back to each of those three players from here. So looking at the code here, there are two interesting facts. The first, okay, when we receive submissions from those first two players, we don't send a response directly. We store the information, but we didn't send a response directly. Actually, the results, all the results are being sent back to all three players only when processing the submission from the third player. That's the first interesting fact. The second thing is that looking at our code, this code works fine. If you just write, it works as should. We're not using any sleep function calls here, and we don't use any AJAX calls here. So by looking at this example, I would say the whole programming experience with Swoole is different from what we used to do with PHP FPM. And that is something really to keep in mind when using Swoole. Okay. So this part is about web server, how to build a web server using Swoole. And then the next part we are going to discuss is how to support task queue in our application server. Now, before digging into it, I'm going to ask a question, which is, and this question is for someone who have played with Swoole before. And the question is, how to add or dispatch a task in Swoole. How to add or dispatch a task in Swoole. And if you have played with Swoole before, you probably will come out a solution like this. Okay, we are going to use a callback function listening to the task event. Anytime there is a task being created or dispatched, this callback function will be triggered, be used to process the task, but how to dispatch a task. And a task will be dispatched by calling the task method on the server object from somewhere in our system, like here when we are processing HTTP requests. We call the task method on the server object to dispatch a task. So this kind of like a perfect answer to the question, how to add or dispatch a task in Swoole. But the thing is here, we're talking about task queue. We're talking about task queue. So is this really the best or proper solution to support task queue in Swoole? Can we use this solution to support task queue in Swoole? Well, to make it easy to understand, I will break the question into two parts. The first is, what is a task queue? The second is, what is the purpose of the on-task event in Swoole? So the first question, what is a task queue? A task queue, it allows the application to perform some task asynchronously or at a later time. But what is the purpose of the on-task event in Swoole? To answer this question, let's check another picture here. So here, this picture shows different types of process running when a Swoole server is started. Okay, so there are three types of processes here: a master process, a manager process, and a bunch of worker processes. But don't worry, let's just forget about the master process and the manager process. I know if you haven't played with Swoole before, you've seen this graph, you see, oh, it's terrible. But don't worry, because we don't need to care about the master process or the manager process as PHP engineers. The only type of process we need to care about, in many cases, just the worker process. Okay, so let's talk about the worker process or worker processes. So the worker processes, those are those processes to handle our TCP or HTTP requests. And they can furthermore divide into two types: event worker and task worker. So what are event worker processes? Event worker processes are those processes to handle our HTTP requests, to process our HTTP requests. They are the processes to run those fallback functions for the on request event. So, and why Swoole is fast? Because Swoole allows things to work asynchronously. So ideally, all these event worker processes, they should work asynchronously. When they need to perform some IO operations, they need to run them in non-blocking mode. Okay, if there's any IO operation running in blocking mode in Swoole, it will slow down the server dramatically. So, but we know that in PHP, there are lots of things, or most things, they run in blocking mode. Like when you make a database query, when you make an API call, they run in blocking mode. So how we make these things run in non-blocking mode in Swoole? Well, there are a bunch of different solutions for that. And Swoole itself has done its best to make many blocking IO operations work asynchronously. Okay, like PDO queries, like Gazo HTTP calls, but still, okay, it's not everything in PHP can work in non-blocking mode. Okay, like some extensions, MongoDB, Couchbase, and some ODBC drivers. These extensions, they are developed by some companies or some organizations. They just work in blocking mode. So how can we use MongoDB, Couchbase, and things like that in a Swoole-based server without sacrificing the performance? The solution is that, okay, if there's anything that has to run in blocking mode, dispatch it as a task and let it run in a task worker process. So in Swoole, task worker processes are to be used to process blocking I/O operations or some time-consuming tasks. That's the purpose of task worker processes. And for event worker processes, they are just to handle TCP or HTTP requests, and they should always run in non-blocking mode. So having said all this, we can see that the task or the task worker process, the concept is similar to a task queue, but not exactly the same. So the task worker processes in Swoole, it's not the best option to process some asynchronous tasks like in a task queue, like to process some delayed tasks. So, but don't worry about that, because there are always different implementations, different ways we can support task queue in a Swoole-based server. And I will give an example later on in this talk. So the next thing we are going to jump in is about cron jobs, how to add cron jobs in our application server. And I would say this is probably the easiest part. Assuming that we need to add a cron job into our application, and this cron job mostly is to deal with some I/O operations. So I probably mentioned some I/O operations previously, like database queries, like API calls, but it's not only about that. There are more things, okay, like DNS lookup, like file read and write, and things like that. Those are all I/O operations. If we add a cron job to deal with operations like that, the best way to implement, to add it in Swoole is something like what you are seeing on the screen, just like 6 lines of code. I know we have some new methods being used here, so I will write in a slightly different way so that we can easy to understand it. These two styles, they work pretty much the same. Okay, so what we're going to do here is that, okay, we will create a new coroutine using the Go keyword. And inside this coroutine, we have an infinite loop there that runs forever. And it will run the cron job once a while. So in this example, it will just print out hello world every 3 seconds. That's how we add a cron job in Swoole, if this cron job is mostly just to deal with I/O operations. So I assume that when people looking at this example, they will have questions. They will feel like unsafe because we are using some infinite loop here, and secondly, the code runs directly within the same process, same PHP process. So people don't feel comfortable with it. But I would say don't worry about it. As long as this cron job or this new coroutine is mostly to deal with I/O operations, the side effects to your application is very, very minimal. But don't worry about that. And another thing I want to add here is that look at the code. When we need to add a cron job through crontab or Jenkins, those cron jobs runs at intervals of days, hours, or at least minutes. But here in this example, the cron job can run at intervals of seconds or even milliseconds, much more frequently. Okay. So now we have discussed those 3 different components: the web server, task queue, and cron jobs. The next thing we're going to discuss is how to put them together to build an all-in-one application server. You see, in the PHP ecosystem, there are many great frameworks, great libraries that we could build the same thing using different solutions. Okay, and this also applies to Swoole. If you want to build same thing using Swoole, you could do it in different ways. If we want to build an all-in-one application using Swoole, there are at least more than 3 or 4 different ways to do it. I'm going to show 2 different ways here. Okay, so the first solution is kind of like this, as we have seen before. Okay, for the HTTP request part, we are going to add a callback function here, listening to the request event. So anytime there's an HTTP request comes in, this callback function will be used to process the request and send a response back. And for demonstration purpose, here, when we process the HTTP request, we will dispatch a task using the task method on the server object, just for demonstration purpose. And then the task being dispatched will be handled by the callback function of the onTask event at line 8. And this task will be processed by the callback function in real time. So that's how we add a task queue system here. And I have to mention that the task can be added not necessarily when processing HTTP request. It could be added in different places, like when processing a cron job. Okay. So the last piece is how to add a cron job. And we're going to add a cron job in the callback function of the onWorkStart event. So this event is triggered when a worker process is started. And from a previous graph, you probably remember that we could have a couple different worker processes there. So the code here is saying, we are going to add a cron job in the first worker process. And what we do is that we create a new coroutine inside the first worker process, have an infinite loop there to run a cron job every 3 seconds. That's how we build an all-in-one application server using Swoole. So this is the first solution. I'm going to show a second solution, which will be implemented using multiplexing. So let's take a look at it. So still 3 different components here. And the first part about the API web server is the same. We're going to use the callback function to handle HTTP requests. And this part for the task queue system, we need to store the task information into some database storage system like MySQL or Redis. And we will dispatch a task when processing an HTTP request just for demonstration purpose. Okay, the code is not shown here, but don't worry. But here is the task queue system. We will create a new process here, and this new process will be used to fetch those task data from database and process them, then sleep for 2 seconds and do the same thing again, and again. And we also need to bind or attach this process with our server so that the task queue system and the server, they can communicate with each other easily. And for cron jobs, we are going to add another process here. And inside this new process, there will be an infinite loop running inside it to run a cron job once a while. In this example, it will run a cron job every 3 seconds. And the same thing, we're going to bind this process with our server object, so that they can communicate with each other. So this is how we build an all-in-one application server through multiplexing. And there are a couple things I want to address here. Again, the first thing is that how to dispatch a task. A task can be dispatched from anywhere, almost anywhere in our code base, as said, like when processing cron jobs. So task dispatching is pretty flexible here. And the second thing I want to discuss is, you see, multiplexing in PHP used to be a painful experience. At least to me, I don't like to do that. But multiplexing in Swoole is pretty easy, and just like you see, it's not that painful as before. Another thing I want to mention is that, assuming that, okay, you have lots of traffic, you have lots of tasks to process, okay, one single process here is not good enough, then you can create as many more processes you want to process those tasks. Not necessarily just one process for task queue or one process for cron jobs. You could add more, it's your choice. And the benefit of this solution, there are a bunch of advantages here. The first is pretty simple. We have one piece of code there, and it has all those three components in it. We don't use any third-party systems like Jenkins or something else. Pretty simple. And the second thing is pretty efficient. Okay, if we define some variables, some resources, these variables, resources, they could be shared across different components. They could be used by the web server, they could be used by the task queue system, and they could be used by the cron jobs directly. And the communications between these three components are very efficient compared to some other solutions. And also, assuming that, okay, we have some data cached in Redis or APCU, those cached data, they can be used by these different components directly. They can share the same cached data. And this solution is more friendly with Docker and cloud environments. So there are a bunch of different benefits here. But whatever examples I haven't shown, they're just some simple examples. Okay, it doesn't contain lots of features or functionalities there, like error handling, like database drivers, like data validation, and so on, so on, so on. So if you want to really build something for a production environment, you better not do it from scratch by yourself. It will take a lot more time. And if you really want to build something production ready, production friendly, I would say, okay, pick up a framework and start from there, just like what we used to with Symfony or Laravel on top of PHP FPM. So for Swoole, pick up a Swoole-based framework and then build your application on top of it. And there are a bunch of great frameworks there. There is a repository called Awesome Swoole. There you could find different libraries, client packages, frameworks, learning resources about Swoole. So check it out and see if there's anything useful to you. Now, another thing I want to mention is this. Okay, Swoole already fast enough, compared to some other solutions, web solutions, but there's still rooms for us to make our applications even faster. And I would share some thoughts here, just for people who are interested in, like, for example, okay, for database queries or API calls, right? So how to make our database queries even faster? A more straightforward way is we're going to use persistent connections instead of open a connection and close it at the end of the request. So persistent connections is a very helpful way to make our servers even faster. And on top of that, we could think about connection pool. We maintain a list of active open connections there. And those connections, of course, are permanent connections. So these two solutions could make our application server even faster. But that's not it. It's not enough. There could be some more implementations to make our server even faster, which is what I'm going to address: connection multiplexing. So what is connection multiplexing? This is really seen in the PHP community, but it's kind of like this. Let's talk about HTTP calls, HTTP requests. So in the old days, when we need to make multiple HTTP calls, like REST API calls to the server, and we use HTTP 1 or HTTP 1.1, okay, what we do is we open an HTTP connection, we close it, we make another HTTP connection, then we open it again. And this is inefficient. This happens in HTTP 1. And a better way to do that is through something called persistent connection. Okay, we just open one HTTP connection, and then we make one request, then we get a response back. We make another request using the same connection, we get a response. We make a third request, get a response, then we close the HTTP connection. This is called persistent connection through HTTP HTTP 1.1. So this solution is better. So an even better solution is this. It's kind of like, okay, we're still making a couple requests, but instead of waiting the one request to finish, okay, we are going to make all the requests at the same time or just without waiting any other request to finish or to get a response back. Then we start receiving responses from the server side one by one. This is called pipelining, and this is also implemented in HTTP 1.1. So these are two ways to make our REST API calls even faster. Persistent connection, HTTP pipeline. But is this really good enough? Can we even make it better? Assuming that, okay, we build a bunch of microservices, and when we want to make our communications between microservices even faster, okay, and REST APIs very common, but it's inefficient, as we showed previously. HTTP pipeline fast, but how to make it even faster for the communications between microservices? That is called multiplexing. As you can see, like this. Okay, we send a request to the server side and send another request, and we don't have to wait one request to finish before accepting another response back. Instead, all the responses, they could be sent back at random order, at random time, and the client side, they can still handle them without any problem. And this is called connection multiplexing. Actually, it's being implemented in HTTP 2.0, but in the PHP system, it's not an option. It's not an option. So this connection multiplexing, this concept is not common thing in PHP, but it has been implemented in a Swoole-based package called in the Hyper framework. And this solution is even faster than what I have mentioned before, the connection pool thing. It is like 10 to 100 times faster for the communications between microservices. So this is probably too much, but anyway, we are reaching the end of this talk, and I'm going to share some more resources about Swoole here. So for the Swoole, you can find it from our GitHub repository project there. If you are interested in learning more about Swoole and find some more resources about, I would highly recommend to check the awesome Swoole repository. You could find lots of learning resources there and cool libraries, packages. So feel free to check it out. And also there are great frameworks there as well. And if you are new to Swoole and you just want to get started with it, I have a personal project called Swoole by Examples. There are a lot of different sample code there, both server-side, client-side examples. Feel free to check it out. They're all ready to run. And if you want to know how actually Swoole works asynchronously, what is CSV programming and what's the concepts behind them, there is a free online talk about it called CSV Programming in PHP. feel free to check it out. You can also find my slides from the link showing up here. Having said that, that's everything about the talk today. Thank you everyone for being here. I'm very happy to have a chance talking to our PHP engineers in Japan.